Hello, young people. Chapter 1, Lesson 2, Earth's Systems. Here's our first video. I think we'll probably do this one in 3 videos. I'm coming at you from my couch again. It's kind of late. My dogs are asleep on either side of me, wondering why I'm still up. But I gotta get these things made for you. So, here we go. This chapter is all about systems and models. We're going to start by going over a phenomenon. That's what scientists study. You remember that from our last series of videos. And the phenomenon we're going to look at or talk about briefly here is ozone. You've maybe heard of the ozone layer. Well, the ozone layer is part of our atmosphere. Our atmosphere is a system, and we could even call it a subsystem. So, systems are parts that work together to do things that the individual parts couldn't do on their own. That's one way of thinking about a system. And so if we think of the Earth as a system, we have different parts. The spheres, we covered that in our 1.1 videos. So the spheres, the atmosphere, the geosphere, the biosphere, and the hydrosphere. But when your system is big enough, the parts of the system that work together can be systems all by themselves. And so we call those subsystems. The atmosphere is a subsystem of the Earth. The ozone layer is a subsystem of the atmosphere. So let's talk about ozone for a little bit. Let's talk about what it is. Ozone is made of oxygen. You're saying, oh, I know what oxygen is. I breathe that stuff in every day. And you're right. You do breathe in oxygen every day, but when you say I'm breathing in oxygen, when we use that word, when we say oxygen, usually we're talking about normal oxygen gas. Normal oxygen gas is made up of one molecule of oxygen gas. One molecule of normal oxygen gas is made of 2 atoms of oxygen that are bonded together. 2 atoms. Ozone is also made of oxygen, but it is made of 3 atoms bonded together. It doesn't seem like a very big difference, and on a certain level it isn't a very big difference, but on other levels it is. For example, ozone gas here at the surface of the Earth is considered pollution. It's bad for you. It causes respiratory problems. Fortunately for us, most of the ozone in our atmosphere is found 10 to 25 kilometers above the surface of the Earth, where we don't breathe it. And it's kind of concentrated in a very thin layer, and up there, way up there, it does a really important job. And that job is that ozone gas absorbs ultraviolet radiation. Ultraviolet radiation comes from the sun. If we're thinking about systems, that would, now we're zooming out, now we're looking at the solar system if the sun is part of it, but we're not. We're going to zoom in to the Earth as a system, and then we're going to look at a subsystem of that, which is the atmosphere. And we'll look at a subsystem of that, which is the ozone layer. Because ozone is 3 atoms of oxygen, when ultraviolet radiation hits it, it breaks those bonds. But the energy it takes to break those bonds sort of slows that ultraviolet radiation down. It transforms it into visible light, which is not harmful to us. Ultraviolet radiation is harmful to us. That's what gives us skin cancer and sunburns and whatnot. So, that is a phenomenon that we can focus on, and we'll come back to it as we work through chapter 1.2. Systems, and the other thing that we focus on are models. Systems are parts that work together, and models are tools that we use to understand systems. Systems are also often really complicated. Models are ways that we try to simplify a complicated system so that we can look at it, analyze it, and understand it. So, ozone layer, oxygen bonds, systems, models. We'll see you in the next video.